Okay, we're back and we're about to start talking about how we're going to model our blocks in the Tetris game. So we've already talked about some of the attributes that we'll have. The type of point, really we called it the name, and that was going from left to right, we had the O, the Z, the I, another I, and an L and a T. But that's not all that we need to be able to do. We need to be able to reflect things. So there's a reflection. We need to be able to rotate things. So there's a rotation. And there's also a location of each point that's on the overall grid. So lower is going to be a bigger Y, and farther to the left is going to be a smaller X. But what I want to talk about now is how we model each individual piece in terms of the points on the piece. So in object-oriented languages, we often wind up with a setup like this, where one row might look like this with ones and zeros, the one being a brick and the zeros being a non-brick, or some type of form like this. And then you wind up with something like a list of lists in Elixir, where if I had an L shape, it might look like this. But the problem with something like this is that Elixir is an immutable language. And this is difficult to deal with if you have to change, for example, one point in the middle. For example, let's say that we had to change the one that's at 2, 2. So you'd have to basically take that whole list, change it, and then make a copy of the other list, or at least grab the same reference to all the other lists and build a new list out of all those. And that's a lot of work. So in functional programming languages, one of the rules is to try to keep your data structures as flat as possible. And you can see that this data structure has two levels. It has a list, an outer list, and that's one level, and then it has an inner list, and they're the inner level. So we can do a little bit better. So let's think about modeling these shapes in terms of a 4x4 grid system like this. And we can actually just make a list of only the points that we need, so that if I'm grabbing an L shape, I grab this list of points like that and just stick them in a list. And that's what we're going to do with our code. So when we come back, we'll do that next. Okay, we're back to our programming setup. I've got my console. And now, if you're following along and you want to just pull the code in progress, you can pull part 3 from our repo, which is at Groxio Learning, and we're in the Tetris-video repo. So let's go ahead and see what we've done so far. So we have our brick, and that's where we've been doing most of the work. And so I think that I'm actually going to be a little bit heavy in terms of the total number of modules that I'm working with, just so the beginners that are coming along with us can understand how we shape these modules. And the thing that I'm most interested in is as many as possible of the functions in a module should have the brick or the module name right here, the instance of that name, as the first argument. And if you do that, that forms a reducer, but it forms one where the accumulator is first, and that makes it easier to do things like pipe. And that's going to be really important for the composition of the game. And it's one of the Elixir idioms that we work with, which are kind of customs that we maintain to make better code and more common code across the whole ecosystem. So with that in mind, let's do something that will take the name of a block, or maybe it'll take the whole block, and it will create the list of points that's interesting to us, the one that we saw in the earlier in the video with the list of XY coordinates. So I'm going to go ahead and create a new file. This is going to be called points, plural, and this is going to have the functions in the project. We're going to build a module that's Tetris, points plural, and this is going to have the functions in the module that either render points or so basically that work on sets of points. And so eventually we're going to create something. We're going to take a shape that takes a block that's going to render points, and then we'll have functions in here, for example, that'll rotate my points, and then I'll do something. The points on that 4x4 grid. So if we're going to be working with points, these are basically lists of tuples. I should probably have something in this file that takes a block called shape. And if that shape is a L shape, then so if the name is L, so here I'm using deconstruction. I'm saying if the name is L, what I want to do is return a list. And remember, I was creating a list that where since it's a list of tuples, I can decide where I want the 0 of this XY coordinate system to be. And I'm going to choose that my 0 is at 1, 1. That'll just make one less mental translation for me. So to make an L, I'm going to start at 2, 2, 1. And then I'm actually going to mirror the shape that I want. Actually, if you're using the Elixir code formatter, that's going to blow this up. But I don't really care about that right now as I'm teaching. The most important thing for me is that I'm communicating the concepts well. So this is going to return the shape or the points that are related to this structure here. So maybe I should call this points. That's probably a good name. So let's go ahead and do that. I'm going to take that and I'm going to build a shape. I actually like the name shape better. It's just I find it more descriptive. And I'm going to have 5 of those. That's 1, 2, 3, 4, 5. And the ones that I have are, so there's the L, there's the I, and the I basically is going to take that and it's going to go to 4. And then I can do the O. That's easy to think about. So let's move this one down to here, and this is going to be 3, 2. That looks right to me. Actually, yeah, that's right to me. So these are all 2s, these are all 3s, and I go 2, 3, 2, 3. That's correct. And I want another, oh, that's a 0, not an O. That's not going to compile. So I need a Z. And let's go ahead and start with this shape. So 2, 2, 2, 3, that's part of the Z. And now we're going to actually drop something down right here, aren't we? So that's going to be actually on 4, and this is also a 3. So the 2s are aligned, the 3s are aligned. These are all 3s, and I go 2, 3, 4. That looks correct to me. So what am I missing? I'm missing the T. And so the T is going to look almost like this one, but this is going to move up. So I don't need that trailing comma there. And this is going to be 3, 2. So the Y's go 1, 2, 3. X's go 2, 3. All the X's are aligned here. That looks correct to me. So let's see if I can write a quick test for this. What's a good test to write? So I'm going to write a brick test. And I'm going to say brick from, and then I'm going to give that attributes. So if I want to create a new brick, I want to say I want to create, well, tell you what, let's make the new work for us, and let's pass it attributes. And I'm going to take attributes, or this is going to be an empty list, and then for new, we can just adjust this a little bit. So basically, this, think of it as like a wonky equal sign. So I take attributes, and that's going to default. That's going to be equal to the empty list if they're not supplied. So everything should continue to work here. So let's look at the brick test again. And so now it should be pretty straightforward for me to write a test for a few of this. For an eye shape, so let's say new brick where the name is I dot points. So the points, and I'm going to feed that into points, and that is going to give me a brick like that. Okay, and then I'm going to assert, no, this is going to give me points. A point, assert points. So what's a point that's in there? Assert, let's say 2 is in points. Let's take a look at that. Okay, so that was an unmitigated disaster. Let's fix it. So undefined function new brick. New brick 1, okay, because we're passing the attributes. I want the attributes here. Okay, that looks like it's working just fine. So let's have a couple of these. The one with O, so that should have 3 in it for the O shape. And I could create them for the whole test suite, but you kind of get the idea. I think that we should go ahead and think about some of the different manipulations that I could do to the points. So I think I want to create another class that helps us do things like reflections and rotations. But first, let's think about a way to basically move our brick such that it can shift to anywhere on the console. So let's say that I can translate the points, and I could translate them. Every single one of those points, I want to take an adjustment, and the adjustment is X and Y. Okay, and I'm going to say enum.map. And enum.map takes two things. The first thing that it takes is points, basically some type of a list, something that can be counted or enumerated. So in the next argument is a function, and basically this function will be applied to everything, to every single one of these things. So basically this is going to be 4 different points. So if I have a function, the function is going to take a point. So that's going to take, let's say, delta x, or the change in x, and delta y. So the change in y. And I'm going to say dx plus x dy plus y. And what this function is going to allow us to do is, if I have a bunch of points that represent a shape, and if I have a location that comes from my Tetris board, this will move all of the shapes to the new location. We can see how this works now. So let's go ahead and give that a try in our console. So now we're in the console. Okay, so we're broken here. We like errors. So line 3 is broken. It says anonymous functions are expected to be defined with this inside the FN block, and it's not. Aha. So basically, I had a mismatched parent right here, and that's not what I wanted. So basically, I have a function that takes a point, and it returns this. Basically, I adjust the point by x and y for every single element in our shape. So let's try that again. Okay, so we're still broken. I bet I didn't save, and I didn't. And here we go. So attributes is unused. So that's in brick 9. So this is attributes. Is that going to work like that? Oh, I see. Okay, so all my warnings are gone. Basically, it was complaining because I was creating these things, but I wasn't actually using them. Okay, so let's try the translation. So we can alias Tetris brick, and then I can get a new brick. So I get a new one because I wanted a predictable X and Y. I don't really care about the rest of this stuff. So we're going to translate that though. So let's see, this is Tetris brick, and the points is Tetris points. So I could say alias. So that's alias, and I could say points, translate, but now I need points. Luckily I can get them. I can say I have a brick, and I can pipe that into brick.shape, and then I can pipe that into, well, I already have points.translate. So maybe the best way to do that is to take this code and just build a longer little pipeline like this. Maybe that illustrates what's going on better. So I start with a brick, and I feed that into the shape. And that's going to give me a list of points, and then I can translate. But the translation is going to take an X and a Y. So let's say change everything by 1, 1. Or 1, 1. Let's see what happens here. Okay, what's breaking? So I have no function clause matching, right? Because I was basically, I was taking a shape. I wasn't taking a brick for that whole shape. So let's see if there's a better way to do that. So I think maybe it would be better here, instead of taking an individual name, well, I am taking a brick here, aren't I? So it's saying that that my shape, oh, I see. So this is shape, and these are all points. Let's recompile that much. Okay, so let's see how we did. So if I had something before the translation, brick.shape, I come up with 2-1, 2-2, 2-3, and 2-4, and it's added 1 and 1 to both x and y all the way across. And what if I do that translation again? Or what if, say, I just want to drop things down one, so I just say points. So points.translate, and I'm going to drop things down one, so I'm going to say 0. Don't move the x at all, but add 1 to the y. So now I should have 2 added to the y all the way across. So 4 gets 2, 2, 2, and 2. That's correct. And 1 should be added to the x all the way across, so it looks like we're working. So this is probably a pretty decent start to a test. So let's steal that code and see if we can make that run. Okay, so let's say test should translate a point. Should translate a list of points. So normally I would add this to a points test, but I don't expect to write as rich a set of tests for these examples as I might otherwise do. But I probably am going to need a new shape. And this isn't B, right? There's no B that exists. So let's create a new brick. And like that. So in the new brick, this is going to be of type O, isn't it? So let's go ahead and say the actual is equal to my new brick with all those translations. And then I could say assert. So let's call these points, actual points. Assert points. Actually, we can do a full comparison, can't we? But I'm gonna actually let the test calculate these and then see if I'm wrong. Okay, let's see. Undefined function points. Let's fix that. Points.translate. I'm going to alias Tetris points like that. I'm going to recompile this beast or mix test this beast. Okay, so undefined function points on line 36. New. Okay, so it's also given me a problem in the test itself. In the test itself, okay, new brick, it's being expanded. New brick, which is right here. Okay, so we dropped our compile warning, but we haven't dropped the error yet. So undefined points on line 36. Line 36 is right here. Okay, so I haven't got a function called points. So let's see. Actually, we called that shape, didn't we? And actually, I don't need the parentheses there. Undefined function points again on line 43. So I did the same thing on 43. Okay, excellent. Now we have we've made some progress, and this says brick.shape is undefined because brick is not available. Okay, that's because we've imported it, but we haven't aliased it. Okay, so now we have a failure. This is what we were expecting. It took a while to get here, but we did. So now let's see if we like these points. So we actually move things 1 and 1 for both x and y. So y should be moving by 2, and x should be moving by 1. And it looks like this should be 2, 2, 3, 2. And so that's correct so far. Okay, this is an I shape. So 3, 4, 5, 6. So we've shifted to the right once because everything starts at 2. And we've shifted down 2 because everything starts at row 1. So it looks like we are in good shape there. So I believe that. And we've stolen these points for our test. So now our test should pass. And sure enough, it does. That's probably a good place to stop and take stock of where we are. I think the next time we're ready to do some more sophisticated things with our points. Like we can think about how to rotate and reflect them. And that's probably a really good thing to take on for the next lesson. So join us next time. Keep staying with it. It's a fun problem.